Hello there, welcome back to Maths is Easy and Fun online class. My name is Marcus Ni Ajeolan. You can call me Nibi. Today we are going to talk about indices or exponents, or sometimes we call them powers, and also root of numbers. It's also an area that I struggled with time, so I am happy I could make it easier for others to enjoy. So you need to follow this. So we're going to talk about indices. We're going to talk about the rules of indices. Okay, we are not going to talk about it the way you learned it. So don't think we are going to do the same thing. You are going to learn how to even understand without chewing the rules. Rule number 1 says this or that. No, you are not going to do that this time around. So please just follow the class. We're going to learn the easiest way of remembering these things, because nobody is going to ask you what is rule number 4 of indices. No, the application is the most important part of it. So we are going to go through that, and with time we'll also cover roots of numbers. Okay, and we'll know how these things will be used as we move on. And believe me, when you follow keenly to this class, by the end of the class you'll be a happier person. You'll be better than you were before. So just follow and we'll be doing that. So let's go to indices. Let's start with the rules of indices. Okay, so just like I said, indices or exponents are just the way to contract a long list of numbers. Okay, so that instead of writing it so wild, you just bring it together and make it very easy to work with. Okay, and it also poses a lot of problems for students. We are going to simplify them so much here that you will enjoy every bit of it, I promise. So what we are going to do is to learn the basis of indices. Okay, indices, when you see it's made of just a number, that is a number which is the bigger number, which is the base, and an index, that is the number of times that number is multiplying itself. Okay, so indices talks about the number of times a number is multiplying itself. I know with time we realize that it's not always possible a number will be multiplying itself, because we have negative exponents and we also have fractional exponents, but we'll talk about them. But the basis shows that there is a power on the number or an exponent or an index. Okay, so as we can see here, you see that y raised to the power 4 or y exponent 4, okay, is the same as y times y times y times y. It means that y multiplies itself 4 times based on the power that it is carrying. Okay, so let's get this one. Anytime you see anything in this form, the bigger number, that is y for this case, is our base, and our index or exponent is the 4. So our index or exponent is the 4, whereas y is the base. You need these two things. It will take us a long way, because I'm going to base on this to explain all the laws of indices. We are going to take this to explain all the laws of indices. So let's bear in mind that we don't have any problem if we understand this basics. So just understand that there is a base and a power or exponent. All you are going to do is to be able to break this down, and you can get all the laws. So you don't need to memorize any laws as we move on. Okay, so let's see an example of how to expand stuff like this. So if you have a squared like we have here, a squared like we have here is the same as a times a. So a multiplies itself 2 times. If you can remember, we said the base multiplies itself the number of times the index is, okay, except in cases of fractional index or negative indices, which will be taken care of with time. Okay, so now we have another one. This time around we have an expression raised to the power 3. Okay, don't worry, treat this in the parentheses as one number. Okay, treat it like you are treating a single number. Okay, and so it means that this thing here is going 3 times. So b plus c multiplied by b plus c multiplied by b plus c 3 times. So the base this time around is not a single number, but it's an expression, okay, which you can call binomial expression because there are 2 terms inside, but that is fine. We'll come to those terms later. But what matters is so far as they are under the same parentheses and the power is over all of them, it means that they are repeating the same pattern 3 times. Okay, this time around, the next example, we have n cubed. It means that n raised to the power 3, but it's what? Raised to the power 2. So it means that you write your n cubed once, n cubed twice, multiply. Just keep doing this like we did. So if you understand these basics, the rest will be so easy. You don't need to memorize rules. Please forget memorization of rules. It will not help us anyway, in any way. So take it easy, relax, just understand the basics, that when something carries a power, when we get to the side where we cannot be multiplying by itself the number of times, we will sort that out. There is a way to work with that as well, but for now let's deal with a whole number or positive integers, what do you call it, whole numbers. Okay, positive integers, sorry, and let's see how it works. So let's move on. So we'll be standing on this basis to build on everything. So remember once again, okay, remember once again that any base raised to the power the index means that the base is going to multiply itself the number of times the index there shows. Okay, so let's get going. Okay, so as we can see, the first law says that if 2 numbers or variables are multiplying themselves, 2 or more, it doesn't matter, it can be 3, it can be 4, so far as they have the same base, that is the key. So far as the same base, you can just add the indices on top of one of the bases. Once again, so far as 2 or more numbers have the same base, the base is a. So far as they have the same base, okay, the base is a, so we have a as the basis. So far as they have the same base, all you do is just keep one of the bases and add the indices. So the indices are m and n, or the exponents. They must have the same base before you can do what I'm saying. But should we memorize this? No, and no again. So all we are going to do is, anytime you find yourself with a problem, whether the bases are numbers, whether the bases are fractions, whether the bases are exponents, okay, I'm sorry, whether the bases are variables, all you need to do is remember the first law. Give yourself a simple example. So let's give ourselves an example here. Our example is going to be, let's take a, let's maintain the a raised to the power 2 times a raised to the power 3. Okay, so we don't even want to think about law, so we are going to do what we were told. A raised to the power 2 means that what? A times a, right? And a raised to the power 3, there's a multiplication, so you bring it. A raised to the power 3 means that what? A times a times a. So we've dealt with the a times a, which is the first, which we've already learned already, and we have a. So okay, let me bring the times. Then we bring the last 3. a times a times a. So we now find out, we get 1 2 3 4 5. So we get a raised to the power 5, which is the same as a raised to the power the 2 on top plus the 3. Do you get that? So you don't need to memorize. If you forget, if you have a question like this, maybe a question like 6 raised to the power x times 6 to the power y, find the answer, and you forget, just give yourself a simple example. Okay, do you get that? Just give yourself a simple example. So you don't know if it's 6x plus y and you've forgotten. All you have to do is what? Choose a simple example like maybe x raised to the power 2 times x raised to the power 3. So x raised to the power 2 is x times x, and there's a multiplication here times x raised to the power 3 is x, x, x. So you count all together, you get 5. So you get x raised to the power 5, meaning that it was 2 plus the 3. So this one will give you what? 6 raised to the power what? X plus y. You get it? Is that clear? That is how you prove. All you needed to know is to know how to break a single thing down into its factors, okay, or expand an index form into the general multiplication form, and then when you do your simple things, you get your answer. I believe that is clear enough. So the first law, we've taken care of it, which says that any number when 2 bases, it could be 3 the same way. If it's 3 bases, it's the same thing, but the bases must be the same before you can do that. Remember, you can only do that for bases that are the same. You cannot do that for bases that are not the same. So instead of thinking and remembering, just give yourself a simple, very simple example. It could be a raised to the power 1 times a raised to the power 1, and you will see that it will give you a raised to the power 2, because a raised to the power 1 times a raised to the power 1 will give you a raised to the power 2, which means a raised to the power 1, it's 1 plus 1. Then it means that you are just adding the exponents on top of it. I believe this makes sense. Okay, so we'll be using the same ways to be solving the rest. So once again, when you are given indices and you have to multiply bases of the same, okay, you can just keep one of the base and add the indices. Do not chew this, do not memorize this. You can prove it anytime within a twinkle of an eye. You can do that, and I know you can do that. Okay, so we'll go to the next one. Okay, so let's check the second law. The second law says that a raised to the power m divided by a raised to the power n is equal to a raised to the power into bracket m minus n, bracket close. Okay, so this is another thing people are memorizing. Law number 2. Remember, in math, they don't ask you to define serves, they just make you work. They'll give you the work so that you think about the principles you need to use. If you forget this, don't worry. All you need is to remember the basic one. What is the basic one? Give yourself a simple example. So do a raised to the power, do your a raised to the power, let's take a raised to the power 5 divided by, because it's division, a raised to the power maybe 3. Okay, so it will be equal to what? You know, a raised to the power 5 is what? A times a times a times a times a, 5 times, divided by what? A times a times a. How many times? 3 times. So now you can start cancelling. You cancel them one by one because they are all factors. You cancel them. Okay, so you cancel 3. You cancel 1 1 1 1 1 1. So you cancel 3, and it will be left with what? A raised to the power what? Because it's this times this, a raised to the power 2. Okay, so you realize that it is just the same as what? A raised the power, the top one, that is 5, minus the down one, that is 3, top exponent and down exponent. So you get A raised the power 2. So there's nothing to memorize here. When you see it and you are confused, write it practically. Give yourself a simple example. You don't need to choose big numbers, but make sure you have the same base, especially when the question has given you the same base. When they have different bases, it will be explained later. Remember, the bases must be the same. If the bases are not the same and they have a common factor base, please find that factor and we'll work examples on that. But you understand what this means. So you now know that if this is your m and this is your n, it is what? M minus n. So that is why when you have a raised to the power m divided by a raised to the power n, it will be a raised to the power m minus n. That is the second law. I hope that makes sense. Yes. Okay, so we finished with the second law. You don't need to memorize. All you need to know is to expand anything in index form, and if you have to multiply, you have to divide, you know. Okay, so we are done with that one. Let's go to the next law. So here we go with the third law of indices. The third law also says that what? A raised to the power m or raised to the power n equals to a raised to the power m times n. Okay, once again, do not worry yourself, don't confuse yourself, give yourself a simple example. So let's take that example. Let's take let's take a raised to the power 3 or raised to the power 2. You know what we said, it will be a raised to the power 3 times what? A raised to the power 3, right? Because this, we are squaring it, so this one comes 2 times. But we can break this thing down as well, right? So we're going to get a times a times a for the first one. Then we'll come to the second one, a times a times a for the second one. So we now have 1, 2, 3, 4, 5, 6, 8. So a raised to the power what? 6, which is the same as what? A raised to the power 2 times 3, or 3 times 2. It doesn't matter. So you see that it means that all you are doing is just when you have something like this, you are multiplying the exponents on top of there. So this is what it means. So do the same thing. That is why we have this law. Do not memorize. I hope it is clear, because 2 times 3 gives you the 6 here. So the moment you are giving, give yourself a similar example, very simple. Don't pick huge numbers. So you can remember, like I said, easily a raised to the power 3 squared, it will be a raised to the power 3 times another a raised to the power 3. So when you have to expand this one will be, in fact, even if you forgot, this is just like the old one we did. Now we have a raised to the power 3 times a raised to the power 3, so it's the same as a raised to the power 6, even if you don't expand. And a raised to the power 6 is 2, the tops, that's the 2 and 3, so it's 2 times 3, that will give you that 6. Otherwise, you expand it and count the number of a's and put it there. Remember that it came as a result of 2 and 3, so now it's raised to the power 6. Is that clear? I believe so, but your questions can come later. Okay, so how is it going so far? I believe you are getting things so gradually. Don't rush it. We'll get it even more. I know you're enjoying it. You enjoy it more. Let's keep working more. Okay, so a raised to the power 0 equals to 1 is the first rule. So now we're talking about rules of indices. We talked about laws of indices. There were 3 of them. Now there are basic rules that we need to know. Okay, please, once again, don't worry, we are using the same basis. Nobody will ask you all those questions, name rule 1 or rule 2 or law 1 or law 2. Nobody will do that. All they will give you is a question to answer, and if you know how to work around, you'll be fine. So the same thing is what we are going to do. It will be very easy for us to do it this way. So what we are going to do is we're going to use the division rule that we just used, which says that we got an example that says that, let's take the a raised to the power 3 divided by a raised to the power 3. Okay, so it's the same as, we can write this as a times a times a, which is the first a raised to the power 3, divided by a times a times a. Okay, so it will cancel out. Okay, and we get what? 1. Okay, we are not going to get 0, we get 1. But if we use the law says that a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. Okay, so lucky enough they are the same numbers, so it's the same as a raised to the power m divided by a raised to the power m. Okay, so a raised to the power m is going to get what? A raised to the power m minus m, which is the same as a raised to the power 0, which was the same as 1, because if it's m is 3 and m is 3, it's the same thing. Do we get it? So let's take this again. We're going to take this back again. We are going to use the division rule to prove this. So we know a raised to the power 3 divided by a raised to the power 3 is going to give us a times a times a divided by a times a times a. Or we can use the shortcut where we know that it is a raised to the power 3. Sorry. A raised to the power 3 minus 3. You remember when we did that? We've already learned the rule already, and it's the same as this. So when you divide this through, you are going to get 1. But a raised to the power 3, a raised to the power 3 is going to be what? A raised to the power 0. And since we got 1 and it's the same as a raised to the power 0, it means that a raised to the power 0 equals to 1. Okay, so that tells us that it's so easy. It tells us that per the rules, any number raised to the power 0 is 1, and it can be proven with this or that. With the rule, we know that a raised to the power m divided by a raised to the power n is a raised to the power m minus n. But this time around, we are lucky we were able to break it down this way. So this is how we prove that. Okay, so let's see the next law. Okay, this is our next example, our next rule, which says that ab all raised to the power n is the same as a raised to the power n, b raised to the power n. Okay, please, let's get it well. We'll still be using the way we started, and we'll be doing this very well. So bear that in mind. We are not doing any magics here. So just give yourself a simple example. Just maintain your AB. Okay, and raise to the power maybe 2. Okay, you remember we break this down because you want to know why it was like that. So we're going to get what? AB multiplied by what? AB, right? Just do what you were asked. Don't just do shortcuts. Just do what you're asked to do. So now this will give us A times A times B times B. So we're going to get A squared B squared. So you saw that the 2 is now distributed on top of them. Don't do magics. Work practically. Do what you were asked to do. You have AB. Write AB. Multiply by AB. Because we get confused in case you get something like A plus B all squared. You don't just put them on top of them. This will give you what? A plus B times A plus B. So you realize that the answer will be different from if you just put it on top of them. So it is not like this. A squared plus B squared. No. Please, it is wrong. This is totally unacceptable. Okay? Don't do it. So what we understand is just expand it the way you were asked to. So you are given something like this. For you to understand this law, all you have to do is to give yourself a simple example. How is our example given? We just wrote our AB there and put a number there so that it will be real. The variable there we cannot work with. Okay, so we should know. In fact, it could be an expression, it could be anything, but you don't worry. Use a simple number and just replicate what you saw. Okay, so you realize that when you do this, you're going to get AB times AB. So it will be A times A, B times B. So you get A squared, B squared, meaning that you are having, if you have A, B to the power 2, it means it will be A squared. It will be distributed over them. Please show working. That is why we are learning this. You don't want to rush into doing any magics. It doesn't help. You rather struggle and you learn nothing. So use the basics so far as you can expand simple index notation or index, anything in index form. You'll be able to work through this easily. Okay, thank you. Let's go to the next rule. So like we said earlier, we are not going to memorize anything. We are not going to memorize anything. We are not going to memorize anything. All we are going to do is to use our basic laws that we learn. In fact, basics of the indices that we started doing to explain to ourselves everything. Okay, so if we have any example, with so if we have any example with negative index, like I told you, we'll work around it. Negative index, we'll work around it. So let's do this. Let's give ourselves an example of A raised to the power 2 divided by A raised to the power 3. Okay, we are going to get what? A times A divided by A times A times A. But if you can remember the rule, it's going to be what? It's easy that way. If you can remember the rule, it is A raised to the power 2 minus 3, which will give us what? A raised to the power negative 1, right? So that is when you are using the rule. That is the one we learned how to do by ourselves. So it's the same thing we are doing here. So you see that this gives you A raised to the power negative 1, whereas this gives you what? This cancels, so we get we get 1 over A. So you see that A raised to the power negative 1 is the same as 1 over A. You get it? Are we getting it? Let's give ourselves another example. So you'll be using a combination of breaking it down and the rule to understand. So let's take, we have A raised to the power 4 divided by A raised to the power 2. Okay, so what we are going to get is, we know the rule, so it's A raised to the power, we need to get the top one to be bigger. So let's get back. A raised to the power 2 divided by A raised to the power 4. Okay, by the rule we know it's A raised to the power 2 minus 4, which is going to give us what? A raised to the power negative 2. Okay, that is one way of solving. The other way is this: a raised to the power 2 divided by a raised to the power 4. It goes like this: a times a divided by what? A times a times a times a 4 times. Okay, times a 4 times. So we cancel 2 of the a's, we cancel 2 of the a's, so we are left with what? 1 over a raised to the power 2. So these two are the same, this answer and this answer. So a raised to the power negative 2 is the same as 1 over a raised to the power 2. You get that? The working is rough, but the understanding must be there. So you use a combination of these to explain this to yourself. So in short, if you've understood how it was done, you should know that when you have any number, if it's raised to the power a negative number, it means that it is a fraction. So it is rather 1 over a raised to the power 2. Okay, the same way, if you have 1 over a raised to the power negative 2, it is the same as what? A raised to the power 2, because it will come up. So it's like when you move a number from the one side of the equal sign to the other, the sign changes. The same way, when you move an exponent from change it from numerator to denominator, it changes sign. The exponent changes sign. But this is the working, this is the explanation to that. So it's not like you need to memorize anything. You need to just remember how to work your way back. Okay, for you to, because you've already learned subtractions and additions of exponents when you are multiplying, or you can know how to rearrange things so that you get a way of proving yourself why it was negative, why it was positive. You know that when you divide, it means you are subtracting. So if a numerator, that is the index of the numerator, is smaller than the index of the denominator, then you know that you're going to get a negative, and it tells you that it's a fraction, which we just solved. The same way a raised to the power 0, so you can do the same thing. Is that clear? Okay, your questions too can follow on our social media channels if you did not get it well, but take it easy, take it slow, and you will understand. Let's go to the next rule. Okay, next rule. What is the rule saying? The rule says that a divided by b all raised to the power n will be equal to a raised to the power n divided by b raised to the power n. Again, no thinking. We just go back to what we've been doing. So you give yourself a simple example. So your example can be like, I should remember this. Your example can be like a over b all raised to the power, let's say 2, will be equal to what? You know what we said, a over b times another what? A over b. Okay, so this is done. So you know that you're going to get what? A times a over b times b, which is going to give what? A squared over b squared. So you saw that this is just, so please, once again, do not waste time trying to memorize these things. Give yourself a simple example. That alone gives you an idea what your answer should be. A very simple example. Give yourself a simple example. I know you won't go through all these steps. Immediately you are able to expand this by putting real number as the index. Normally the easiest thing to do is find a real number and use it as the index. Okay, and just expand. Then you know the rule. So you know that when you have something like this, it's easy. It gets to the numerator is the power, the index divided by the denominator raised the power, the index. As simple as that. So that is the rule here, which you don't need to memorize. Okay, thank you. And we'll go to the next rule. Okay, so as you can see, there is a new one here. We are going to find the rule by ourselves. Okay, so we are going to have fun. Okay, you remember this, right? What did we say? It means that when there is a negative exponent, it means that it's rather to make it stand on its own, it's going to be, so let me give a quick example. If you have a I should remember this thing. If you have a raised to the power negative 2 is the same as 1 over a squared, okay, which we've talked about already, that when it's negative, when you bring it down, it becomes positive when you bring it. So let's take this one that we have here. So this one is going to give us what? 1 over a raised to the power b, or raised to the power what? N, right? And we already know that, so 1 divided by what? A raised to the power n, b raised to the power what? N, right? We've already solved this. Okay, so it's still 1 divided, so we change it to be 1 times, sorry, so 1 times b raised to the power n over what? A raised to the power n. That is, when you are doing multiplication, when you are doing division, you change the division sign to multiplication and you find the reciprocal of the second what do I say, the numerator, I mean the denominator. Okay, so you understand that. So 1 divided by this, that is what we wrote it this way, and we know that it will be a raised to the power n over b raised to the power n, and we'll do multiplication, it's b over, so now our answer is going to give us what? B raised to the power n divided by what? A raised to the power n. So this is the answer. B raised to the power n divided by A raised to the power n. It's not difficult. All you need to do is to take your steps well and be careful as you do these things. You don't rush it. Okay, so take the simple rules and explain them to yourself. Keep practicing and it becomes part of you. Okay, yep. So let's see the last rule, and that is the fractional index. Yep, so we are on roots of numbers now. So fractional index is when roots come in. Okay, and also we are going to do this so easy. Why am I saying this? So let's take it that you have a let's take this color, a raised to the power half. Okay, it is the same as square root of a. Okay, so it so square root of a can be reversed to be this. Okay, so this is a simple one. So when we have a raised to the power 1/3, it is the same as the cube root, where that one you see 3 here, of a. The same way when you have the cube root of a, you can write it back this way. That is all. That is all for that. So in case you want to, as we move on, we'll learn how to take off the roots and all of that. Okay, so let's take it that you have the 8th root of b. 8th root of b can be written as this, with 8 here of b, or we can do what? We can write b raised to the power to 1 over 8. That is all. Okay, that is all about 8 roots. And normally when we are not learning this for learning's sake, we are learning so that we can use them to help us simplify stuff. Okay, so let's get an example of these things that we have here. So if we have like we have square root of, let's say, 4. Okay, we know that it is the same as what? 4 raised to the power half. Okay, lucky enough, for us to get rid of the half there, it means that we have to multiply by 2, and we are lucky that there is a number that when we square it, we are going to cancel out the half there. So it is 2 raised to the power 2, that is the 4. Okay, raised to the power half. Does that make sense? Okay, so you know our rules. So it will be 2 raised to the power 2. Sorry, let me get my pen writing well. 2 raised to the power 2 so it is equal to 2 raised to the power 2 times half, which is the same as what? 2. So you see why square root of 4 will be 2. Okay, so that is it. So let's take another one, another simple example where it says what? Cube root of 8. So cube root of 8, okay, which is the same as 8 raised to the power 1 over 3. Okay, and we know that 8 is 2 to the power 3. Okay, and we also have 1 over 3 there already. Okay, so we move on and we realize that 3 will, since we learned and we know that it will expand, the indices will multiply themselves. We are going to get what? 1/3 times 3, which will give us 2. So cube root of 8 is 2. We'll be using these rules to work a lot of examples. In fact, not in this class, but later on. So you need to learn these rules, learn how to prove them, learn how to get them, because you are going to work with them. And you need to remember how to make your bases. Okay, remember how to break down bases to get a form that you can work with. Sometimes you may not be given the same basis, but you have to. With the knowledge of arithmetic, you have to be able to break the number down. So if you have a question like this, 2 raised to the power 1 times 4 raised to the power 2, and you are supposed to do, you don't have the same index, you don't have the same basis, so you cannot work except you change the basis. So here we get 2 raised to the power 1 times what? 2 raised to the power 2 for the 4, but there is another 2 on top of it. So you're going to get 2 raised to the power 1 times 2 raised to the power 4. Okay, so that you can now say that 2 raised to the power 1 plus 4, which is 2 raised to the power 5. Okay, so sometimes you have to be changing the basis. So this is just a demonstration to know the rules just by heart. I know you might have learned a lot of these things, a lot of stuff like this in school, just that sometimes you need further explanation to it so that you can apply to what you are working. So look for more examples and start working, and you will be fine. Okay, and your questions can always follow on our social media handles, where we will take care of them. So when you find questions and you couldn't know how to approach them, please contact us and let's work on them. So that is the end of indices and roots of numbers. Like I said, we are not taking it so deep. We want to explain the principles that are very difficult. You can bring your questions. Don't get bugged. Don't get angry. Take these classes again. Repeat. Watch over and over and understand, especially from the beginning, the rules that we're given. If you're able to follow these rules, you understand things better, and you'll be ready to face other questions. Even if you cannot, when you are reminded, it's easy to remember what you were told if you actually follow, and you just cannot apply it. Application will be easier. So one thing is to understand the principles, conk, then application will follow, and we are there to help you along. So good job, and let's continue. Finally, we are done with our lessons on indices or exponents and root of numbers, and I believe you've understood things even better. Nevertheless, if you think you like what went on, please visit our social media handles and Facebook, Instagram, and YouTube, and just like, comment, and let us know what you felt about the class. Please, it's not only when you have a problem that you need to talk to us. Tell us if you are enjoying what is going on, okay? And one thing we want you to do most is on your YouTube channel, please go and subscribe. It's very important. It gives us the strength, the energy to do more for you. Also share with other mates of yours, other friends, anybody who may need this, so that we all enjoy and do well. We love working with you, and we believe you also love working with us. Catch you again another time on our next topic. Take care, stay safe, and stay home. Bye-bye.